Welcome to this contact center technology overview. This presentation is given to you by Expertflow.com. Everything that I'll be presenting here is solutions that we are deploying turnkey together with our IP telephony partners. Our IP telephony partners are responsible to deploy all the servers, LAN, WAN, and IP telephony infrastructure, whereas Expertflow is deploying all the contact center applications and solutions that go on top of it. Okay, let's start with the basic overview of what happens with the call in a contact center. So a caller calls through a certain number in the public telephony network, PSTN or RNIS in France, and reaches a voice gateway. A voice gateway has two roles. First of all, it transforms TDM, so digital telephony, into IP. So IP telephony. This function is called an ingress voice gateway. And the second function that it performs, it provides a function called egress voice gateway, which allows you to play announcements. So this voice gateway is capable of playing announcements back to the caller. So here you have a little announcement, and you can have voice files playing on this voice gateway. This voice gateway is also called a voice browser, like an internet browser, because it essentially performs the same functions as a web browser. So this voice browser interacts with a contact center server, which essentially works exactly in the same way as a web server would work with a web browser. So if the voice browser asks the voice server what kind of announcement should it play, the contact center server then tells the voice browser to play certain announcements such as, hello, welcome to Expertflow, please press 1 for this, please press 2 for customer service, please press 3 for sales. And the voice browser will then execute that and play these messages back to the caller. So this means that in a modern contact center, the server part of it as well as the voice aspect of it are separated from each other, and this allows for very interesting deployment models. So the voice call remains constantly at the level of the voice gateway, whereas the whole business logic remains on the contact center server. Now the contact center server itself can integrate with certain databases to retrieve information about the customer, such as its account number, whether it's a VIP customer. It can determine based on the calling line ID of this customer here. It can determine, make a lookup and see, okay, do I know this phone number? Yes, it's a VIP customer, give him priority routing or allow him these or that options. The call can later then be transferred based on all of this information. The contact center server can now decide to forward that call to a contact center agent. And pre means that this is a physical voice call. So you see that the physical voice call, which consumes a lot of bandwidth, is going from the phone through the public network to the voice gateway and to the contact center agent here. And there is no large bandwidth requirement going from the voice gateway to the contact center server. This is very interesting because what it essentially allows you to do is you can deploy voice gateways anywhere you want. So for example, let's assume that you have calls coming into a certain country, for example, France or Switzerland, and you provide outsourcing services in Morocco, for example. So the voice calls would be queued in France on the voice gateway, which costs you not very much. And whenever an agent becomes available, whenever the contact center service determines that the contact center agent is now available, the calls will now be forwarded to that agent, but only once the agent is available. And this decentral deployment of voice gateways essentially allows you to save a lot of costs. You can also deploy multiple voice gateways. So for example, if you have a voice gateway in, say, or multiple locations in country services, for example, in Morocco or in Mauritius or somewhere else, you can receive local calls on local voice gateways here, international calls on POPs, point of presences, in other locations and route all the calls to those agents. And this allows you to save a lot of bandwidth cost, which is particularly important in emerging markets where bandwidth still costs a lot of money. At the same time, while we economize in terms of bandwidth, you only need to deploy the application logic one single time, right? Because those servers, this is basically a web server, they can be in a whole pool of servers to accommodate more demand, can be deployed in a single location or in decentral, redundancy, failure-proof locations, and serve multiple physical locations where you have contact center agents. Now, we have seen how a contact center now determines a routing of a call. So the call comes in, reaches the voice gateway, there is a certain business logic that is being executed with a database or by retrieving information from a CRM solution, for example, whether this caller is known. Oh yes, I know this caller most likely calls because of a certain ticket and because he opened a service request in a previous call. So now I know why this caller is calling. I determine the reason of his call. I can maybe play an IVR menu. Please enter your ticket number. Please enter your credit card number. Whatever information I can get in order to increase the information that I have now about this call. And when I forward this call to the agent, I can make sure that the contact center agent gets this information about the caller on his laptop or on his computer. So what I do now is I forward the call information that I have about the caller into the desktop of the agent. So the phone rings and the agent sees here an accept button. He sees the information about this particular customer. He possibly also sees the reason why this customer is calling in his screen and can click the accept button and greet me right away and say, hello, Mr. Stuber, I see you're probably calling because of your credit card expiry or whatever. How can I help you? So there is very little time lost if you have this screen pop up, what is called, so the screen with the customer information here pops up on the screen of the agent, which saves a lot of time for identifying the customer and so on. This screen pop-up can now happen in two different flavors. The first flavor is that we have a CTI application, which basically allows you to log in, log out to the contact center, make yourself ready, not ready, accept the call, transfer a call, and so on, which then controls the CRM application. So if I maybe increase the size of the screen here, so I'm increasing the size of the screen of the desktop of the agent. In the first scenario, I have a CTI application that allows you to control the call and the CRM application. And here, the CTI application controls the CRM application, right? This is pretty simple, but it requires you to deploy two different applications. First of all, a CTI application and your existing CRM application or service management application, whatever you have to manage those phone calls. Second way of integrating is a little bit different. So instead of having a CTI application controlling a CRM application, which is cost effective because we don't require us to do development, most often this integration can be done through certain APIs or HTTP URL calls, these kind of things. Now instead of doing this, the second scenario would be that we have a CRM application and that the CTI toolbar is embedded within the CRM application. So for example, if you have Microsoft CRM or Sugar CRM or Remedy or whatever, you would have those buttons, log in, log out, transfer call, accept call, and so on, embedded within the CRM application. In this case, we call it the CRM connector. So there's a big difference in terms of how screen pop-up is integrated with the contact center. To summarize, the first is you have a separate CTI application, which is cost-effective. And the second alternative, you have a CRM connector, which is more user-friendly, typically costs a little bit more for the base installation because there is typically more development or integration or certain licenses required in order to do this CRM integration. So this is how screen pop-up can be done. One more thing that I would like to mention regarding the calls. Now, if you're, for example, a bank, information is often very sensitive, so you might have issues concerning security, especially as soon as you buy this infrastructure as a hosted platform from a hosting provider. You will not want the hosting provider to have access to the sensitive information such as PIN or customer information or credit card details, etc., etc. So because these servers are basically web servers, so instead of having HTML, such as in a case of in a web server, you just have DXML. It's a very similar format. As you see, it's just those two letters here that change, but technically speaking, the contact center servers integrate with back office system exactly in the same way as the web server would. Actually, the ones that we deploy are running on an Apache Tomcat web server. So now if you have security concerns, you can do exactly the same thing as banks are doing for payments. So if you go on a website where you would like to execute a certain payment, like say Amazon, or you want to book a trip or whatever, you go onto the server of that particular merchant, you want to execute the payment, and now because this is a web server, the web server can refer the payment to the web server of the bank or to a payment provider, who will then execute the secure transaction which can be encrypted via HTTPS here, execute the payment, and once the payment is executed, it refers back the call to the contact center server of the infrastructure provider. So the infrastructure provider at no point has access to the secure content because this can be based on the bank's premises, whereas the whole rest of the infrastructure would be based in the premises of the hosting provider. So this is how security aspects in phone banking and other things could be managed, and how multiple different parties within your company, let's say you have a department for services, a department for sales, or you have multiple internal customers, each one of them wants to manage their own services. All they need to do is deploy a web server that essentially runs their own service, and they can provision themselves as they can do back office integration as they feel like. So this whole architecture about revolving around DXML is very interesting for these various reasons. Just to summarize, first of all, you save money by having the call being queued at the voice gateway. It's also called queuing at the edge. And secondly, you have possibilities in terms of security that you can do. Now, how was it done previously, or how are traditional contact centers, even IT-based call centers, doing this currently? What they are doing usually is that the call comes in, reaches the contact center servers, goes back, and then goes to the contact center agent. And you can see that here, you will spend money in terms of bandwidth. This is typically the difference, let's say in the Cisco environment, this is the difference between Express Contact Center, which is doing this here, versus Enterprise Contact Center, which allows you to do queuing at the edge on the voice gateway. It's pretty important if you compare contact center editions, whether it is functionality. These contact centers that require a call to be routed all the way to the less costly, require a little bit less servers, are highly integrated, provide a lot of functionality in a box, but they won't provide you the same degree of flexibility, scalability, and so on as a XML type of deployment would allow you to do. All right. Another aspect of voice calls that I would like to mention here is mobile agents. So this would assume that the contact center agent is using an enterprise IP phone, which is most often the case. However, if you have a sort of an emergency situation or a peak call volume, a certain special event or thing cannot plan, you might want to be able to involve additional agents on the fly. You can do this by a functionality called mobile agent. So an agent can use his mobile phone, dial into a certain number, and the contact center will be notified that this agent, this mobile agent, is now available to the contact center. So the contact center will reserve an open phone line to this contact center agent, and whenever the internal agents are busy, it will also start forwarding calls to this mobile agent, treating this mobile agent exactly the same way as an internal contact center agent. What we can also do is that if a call has taken place to the agent, we can do something that is called post-call survey, which means that after the call with the agent, the call is then transferred back to the IVR, and the IVR, or the VRU, voice resource unit, or IVR such as the interactive voice resource, are playing a questionnaire to the caller regarding his satisfaction. So for example, was the agent purchased? Was your query answered? How happy are you with the service provided by the company, etc., etc. Or in scenarios such as directory assistance, so you have a call with the agent, you say, okay, I would like to have the phone number of my local bakery. The agent says, okay, bakery so-and-so, yes, this bakery, thank you, I will transfer you to the IVR who will read out the information to you. The call is then transferred to the IVR who will then read out the phone number of the bakery, give you the option to send back an SMS or be connected to that particular extension. So it's not only a call that reaches an agent, but it can also be a call goes to an agent, goes to an additional agent, being retransferred to the agent, and then goes to an IVR service in order to shorten the call. It's extremely important to try and shorten the phone call time, because the shorter the phone calls are, with the same amount of minutes that you spend overall in the whole contact center on voice calls, the more fluid the contact center will become, and the more calls you will be able to transit through the contact center, and by that you would be able to lower the overall waiting time. A technology that is very frequently used in a contact center is what we call skill-based routing. So you might have certain agents here that have screen skills. So this is agent 1, this is agent 2, this is agent 3. So let's assume that 2 agents have a sales skill, 2 agents have services skill, and 2 agents have some other skill, support skill, for example. The blue skill. So each agent is trained on various aspects, and obviously training cost is a very important aspect, a cost aspect in a contact center. So if you can train less agents on mini tasks, and only most agents on basically a certain number of basic tasks, you can say, okay, as long as I have the black tasks being required by these calls, I can route them to any agent, and I will prefer agents who only have, for example, the black skills, right? If the green skill is required, the contact center will select either this agent or this agent, and if the blue skill is required, it will select either this or this agent. By doing this, you can reduce the number of training that is required for each agent, and you can say, okay, I have a certain number of students, people that follow only a very basic training to provide, say, 70% of all services, and I have a very small number of selected agents that have a large training in all aspects of the contact center, which costs me much more. And those agents basically allow me to skip into whatever skill is required at this moment. So this is called skill-based routing, also called competency-based routing in a Cisco context. Alright, so we covered all most of the IP telephony aspects of a contact center. We covered screen pop-up, and we covered skill-based routing. Now the contact center is called contact center because it treats not only voice calls, but it can also treat any sort of media, such as web chat or email. So let's imagine that you have an email coming into the contact center. The email comes in, reaches an email interaction interaction system, very much like a IVR server, can send an automatic response back to the sender. And it can do this, again, by interacting with a customer database. So, for example, it can retrieve information in the email to see, okay, there's a case ID, a customer name, an agent's name, you name it. Anything can be used that is available in the email as text can be used to retrieve information, send back an automatic response as an email, such as thank you very much, Mr. Mueller, your case ID is so and so on, the status is this and that, and an agent will respond to your email in 15 minutes, for example. So at this point, you can also determine how long it will take until an agent would be able to respond manually to this email. Once this is done, the email goes into queuing. So it's queuing here in the email inbox, just like the voice call will be queuing on the voice gateway. And as soon as an agent becomes available, this email is being forwarded to the agent into the email module of the CRM or into a dedicated email module. The agent then can respond to that email, which is then sent back to the sender. Now, the contact center is aware whether this agent is currently available to take the email or not, and you can say, okay, I want to prioritize calls over emails over web chat, or you can say, okay, any email from a VIP will be more important than a call from a normal customer. So you are highly flexible to prioritize tasks and media across all the media and across all the tasks. So the agent will only get an email request if he's not busy taking a call, and while he is responding to the email, you can say he should not get any voice calls, or he should not get any other media, or you can say while he's treating an email, it's okay to receive another voice call because a voice call has absolute priority. So that's something that you can determine here. If the agent is treating an email, again, at this level here, you can do a back office integration with the CRM to automatically insert certain email response text, templates, and things that will allow the agent to respond very quickly to the email sent by the sender. So you can basically write a template, dear first name, last name, thank you for your request regarding, and then you insert the question that you had, and so on. So the agent will then have to write very few manual text and can just select, click down automatic fill-in options for this email. The same is also true for web chat. So a web chat, if one of your customers comes onto a web server, for example, and sees a little button here, click here to chat with an agent, that will again be queued here. You can send an automatic response. You can send video to this particular station. It can also be a video kiosk, for example, while the agent, your customer is queuing. Once an agent becomes available, he can start having a chat session with your customer, which can then later be escalated to a voice or video session if required. The same mechanism here applies regarding automatic responses and so on. You can also integrate basically any type of multimedia that you would like. You're not only limited to email or web chat. You can basically route anything you want to an agent. Let's say you have an SMS server. If you have an SMS server, your own branded SMS server here, an SMS reaches here, so the SMS server can say, okay, dear call center, I have an SMS, and I would like to have an agent taking care of that. So the contact center server tells the SMS server, okay, wait, okay, now I have an agent available, and if you have an SMS client, let's take the color is blue here. So if the SMS server has an SMS client, the contact center will tell the server that on this workstation an agent has become available and that the server should push an SMS session, for example, to this agent desktop, and then the agent would be working with with your SMS application to treat this particular SMS. And again, this SMS server, SMS client is something that you could have already installed, which does not necessarily have to be something that we are providing. Obviously, it's better if we are deploying it, but it could be any sort of media that you would like to route to the agent. The agent can then treat any sort of media that you would like him to handle. It can also be a video session or what have you not. All right, let's quickly talk about statistics in the contact center. Obviously, you will want to know how many calls do I get, how many email sessions do I get, how many web collaboration sessions do I get, in order to predict the number of agents required to satisfy a certain service level. And let's assume that this is the number of calls or requests. This is your time axis. And your call volume fluctuates like this. Now, what I see very frequently is that contact centers are staffed, say, from 8 a.m. with 20 agents all the way to 5 p.m., for example. Now, what obviously happens is that in this instance here, you're providing a very bad service because there are not enough agents available to take calls, and these instances here, the agents are doing nothing and they're idle. Now, what is much better, obviously, is to plan the staffing of your contact center so that it roughly corresponds to the forecasted call volume. This is something that you can do manually, but requires a lot of work, and in contact centers for more than 20 or 30 agents, it's more cost-effective to have a dedicated tool doing this automatic staffing, and these tools are called workforce management tools. So workforce management tools allow you to do staffing according to anticipated call volumes. You can do traffic predictions and say, okay, now I have a marketing campaign and expect so many further calls. And you can simulate cases and simulate the number of agents required, and then the workforce management tool will tell each agent when he has to work, when his shifts are due, and so on. Another aspect of statistics agent-centric might be related to quality management. So you can say, okay, I want to record the calls of the agents, and the calls will then be analyzed and evaluated by quality management staff. They will listen to the calls and score each call according to different metrics. So, for example, did the agent greet the caller properly? Did he use his tools effectively? Did he hang up after the caller, etc., etc.? So all these aspects can be scored. So the agent gets a score for the way how he handles the call, the quality of how he handles the call. It can be combined with screen recording, so the supervisor can verify whether he's actually properly using the tools that are on his desktop. And this score can then be combined with the score from workforce management. So is this agent working when he should be working? Is he taking breaks when he should be taking breaks, and so on. It's actually very important for the overall call center service level performance that the shift staffing is followed practically on a minute-by-minute basis, because only very small fluctuations can have a very positive or negative impact on the contact center performance. So quality management, workforce management, contact center metrics can all be put together into a business intelligence tool that we can deploy, which will then, or CRM information, so customer-centric information and so on, can all be pulled together into a BI tool, business intelligence tool, an Expertflow business intelligence tool that we can deploy to give you an overall view around the contact center. Business intelligence and reporting would be a very long presentation, so I'm skipping that right now. The last aspect that I would like to mention is that from an architectural point of view and deployment point of view, all the services that we are deploying, especially in the enterprise environment, are running in parallel on so the applications are running in parallel on two different servers. Both executing each action in parallel, And if this server should fail, this will automatically take over the call in progress. So the voice gateway, for example, has both servers configured so that if this one fails, the second one will take over the call in progress, and there will be no interruption due to a failure of any server. So you will not even have an interruption in the ongoing calls in an IVR menu. You would not have an interruption if you try to transfer a call. It's not a warm standby solution, but it's a hot standby solution, carrier grade. One further level of redundancy here is that now most of the deployments that we're doing are running on VMware environments, so you can prepare in the background VMware environments or services that you can then activate automatically or on demand if you want to switch services, make upgrades and so on. So you just have this on standby. If this fails, this will automatically be turned on and take over the service of this failed server. So VMware adds an additional layer of redundancy. That's it for a basic overview of contact center technologies. Thank you very much for your interest. We hope to be able to meet you in person for a presentation. Don't hesitate to ask questions if you have any over our website, and have a good day. Thank you. Bye.